All right, let me pause there, because that was a lot, and it was a lot lower level, for any questions. Yeah?
So I get that y'all made a library for us to use, but when you just put a hashtag include that library, where is it getting it from?
Really good question. So when you just put that one line of code at the very top of the program, where is the code? It has been pre-installed somewhere in the cloud, literally in some folder in your CS50 IDE. And because we've installed industry standard software, that software, like Clang, literally just knows where to look on the hard drive to which you have access. So we have a file that we wrote in the past called cs50.c that literally has all of the C code that implements it. In cs50.h, there's really just a summary. A .h file we'll soon see is called a header file. And it literally just has like a succinct summary of the functionality to which you have access, so that you simply have to write one line, and therefore you get access to the whole toolbox of functionality in CS50's library, in the standard IO library, or in something else. That's what you get. Yeah? Exactly. You can use any of these functions, get int, get float, get string. We haven't even talked about what some of those are, but so long as you store it in the right type of variable, changing int to string or string to something else, then yes, you can use any of those to just get input from the user so that your programs are actually dynamic. They're not going to involve mouse clicks and so forth, but at least you can take textual input from the user. Let me go ahead now and open up a program that I wrote in advance. Let me go ahead and grab this here, and it's called int plural. And I'm going to go ahead and open this as follows. So this is code that's already on the course's website too, so you can take a look at it at any time. But it's a little more complicated, but it looks as follows. So at the top of the file, notice it starts with //. It turns out that programming languages like C support what are called comments. Comments are not code. They're just kind of sticky notes to yourself that remind you or someone you're working with or your teaching fellow what the program is supposed to do. And in this case, I want to demonstrate integer arithmetic, whatever that soon means. Now I have a couple of includes, and I've clustered them. I put some blank lines, but that's just kind of to keep everything neat and tidy. It's not strictly necessary. Here I have main, and we'll come back next time most likely to tease apart why we have int and why we have void. But for today, let's just assume that that is the equivalent of when green flag clicked. And now we have a few lines of code here. I have two comments, which literally tell you what's going on, prompt the user for x and prompt the user for y. Beneath each of those comments is the actual lines of code that do that. And how do you think about this line of code? It's pretty similar to what we just saw, albeit with different names. On the left-hand side of line 9, we're saying, hey, computer, give me a variable called x and plan to store what type of data in it? Int, an integer, like a number. And then the next line of, and then on the right-hand side, it literally calls getInt, which is like another version of SAM that goes off and gets an integer from the user, where the user, he or she types it at the keyboard, hits enter, and then getInt returns it to the program. And because that getInt is on the right-hand side of an equal sign, that value, just like Sam handed me a piece of paper, is going to get transferred from right to left and stored in the variable on the left-hand side. So if I type in the number 1, x is going to contain the number 1. Meanwhile, if the next number I type is the number 2, the value y, the variable y, is going to store the number 2 from right to left. And now this is a little overwhelming at first glance, but it's just a copy-paste of some of these same ideas. Perform arithmetic. So I wanted to demonstrate in this program a few arithmetic operations that C supports. You can add numbers, subtract numbers, multiply, divide. It might not be obvious what symbol to use, and that's why we see this. On line 15, we see the following example. We have a string here, which says plug in some value, then literally say the word plus, then plug in some value, then literally say the word is, then say the third value. All of these values are integers because after this highlighted string, I have 3 additional inputs to this printf function, 3 additional values, x literally, y literally, and it turns out that if you want to do math in C, you can literally type x plus 1, and that will return 1 plus 2, or whatever the values actually are. And again, there's 3 values separated by commas here because there are 3 placeholders on the left-hand side. Meanwhile, the rest of this is just like copy-paste of that, but with different words and operators. So something minus something is something. And how do I get that output? X and y, and then x minus y. So minus is what you would expect it to be. X, something times something is something. Well, that's x, comma y, comma x star y. So the asterisk in C represents multiplication. And then x something divided by something is something, x, y, and then x slash y gives you division. And then the last one is probably the only weird one, or one that you've never like typed out on a keyboard. The remainder of something, when divided by something, is something. And that character is the percent sign. So you've probably never written that as a command unless you've done modular arithmetic, but you've thought about it in grade school probably. Divide one number by another. What's the remainder? This percent sign is how you express that same idea. So let me go ahead and compile this program. And again, to recap, what's the most succinct way for me to compile a program that's in a file called ints.c? Make ints. And again, we're abstracting away all those details. And this is going to be a pattern. Just when things seem really detailed and really nitty-gritty, we sort of layer on top of it a simpler way of doing things and just take for granted that we know that something is happening underneath the hood. Make ints seems to have worked because no error messages. So /ints, enter. X will be, say, 1. Y shall be, let's actually do this. Let's do 2. 2 and 2. Enter. All right, 2 plus 2 is 4. 2 minus 2 is 0. 2 times 2 is 4. 2 divided by 2 is 1. Remainder of 2 divided by 2 is 0. I think all of those actually do check out. But I'm a little curious that proof by example is not really a proof. So let's try at least once more. 1 for x, 2 for y. OK, 1 plus 2 is 3. 1 minus 2 is negative 1. 1 times 2 is 2. 1 divided by 2 is 0? What should it be? Probably 0.5, right? Like 1/2. 1 divided by 2 is not 0 mathematically, but remainder of 1 divided by 2 is 1. So for some reason, division is broken. Like my computer does not apparently do division correctly. But why is that? Well, you can probably guess, even if it's not obvious, like why might this be? What's going on? Yeah. Looking for an integer, so 1 divided by 2, and if the output has to be an integer because of the %s, you kind of have to pick one way or the other. And so what a computer program does is it throws away everything at the decimal point. If you are using ints, and ints should not have decimal points, those would be real numbers instead, or rational numbers, we're just going to throw away everything after the decimal point, and we're left, of course, then with 0, because 1 divided by 2 is technically 0.5. So we lose everything after the dot. So how do we fix this? Well, it turns out we can fix this in a couple of ways, but perhaps the simplest is to do the following. Let me go ahead and grab one other example that I wrote in advance. This one is called floats.c. And float is an allusion to floating point arithmetic. Floating point literally is referring to like a period that can move left and right depending on what value you're trying to express. And in this case, notice I've pretty much just changed the program to use not ints anymore, but literally floats. So a third data type. We had string, we had int, and we had float. And float allows our numbers to have periods in them. And so now, if I do some arithmetic here, just one line of it, this is the same line of code as before, but now I'm using %f instead of %i to print a floating point value. Let's go ahead and make floats, enter, /floats, and let's try it again. 1, 2, and now I get the answer I actually expect. So that's kind of interesting. Now I just have to be ever more precise as to what's going on. So we have strings, we have ints, we have floats. Let me pause here too. Any questions now on what are generally called data types, types of variables? Yeah?
How do you increase the number of decimal points?
Really good question. How do you increase the number of decimal points? So we can do this in a very specific way. So right now we have 1, 2, 3, 4, 5, 6 values printing by default. Let's say we want to do 10 instead. It's a little cryptic, but I can literally do .10. Which is just an official way of saying, give me 10 numbers after the decimal point. And frankly, I forget these kinds of details all the time. You just Google and you can kind of pull that kind of information up. Let's go ahead and try it. Make floats. And now /floats, 1, 2. And now I get even more zeros after the decimal points. And you can go the other direction too and sort of do implicit rounding as well. Yeah, question? Good question. Can you make the first 2 integers and make the last 2 a float? So could I do int x, get int, int y, get int, and then change these, of course, to I, I, but leave this as just floats? That's a good question. And frankly, not to be trite here, but anytime you have these kinds of questions when you're on your own and not in an environment like this, literally just try it. And so make floats again. And that's not good, but the compiler noticed that I was doing something that isn't legitimate to do. The compiler, it's always a little cryptic, these error messages, but format specifies type double. Double, turns out, is a floating point value, but with even more capacity for numbers after the decimal point. Long story short, float generally uses 32 bits, which gives you that many zeros and ones with which to represent a floating point value, or a real number. If you use a double instead, you get 64 bits, which, per our conversation in the first lecture, just means you have even more range of values or more precision. So we specify type double, but the argument has type int. So the compiler caught it, and we just can't do it. We could turn off this warning, and we could try to do it, but we might get unexpected behavior. Great question. And was there another question here before? In this area? No? OK. All right, so that's then a different type of value. But let's introduce now a few of those logical constructs that we promised were coming. Let me go ahead and do this. Let me go ahead and grab a file. And all of these, again, are on the course's website called conditions.c. So here's two is a program I wrote in advance that does a bit of logic. I, again, am kind of following a pattern so that each program kind of introduces just one or two new ideas. So I have get int twice, storing the values in x and y. And then I'm just doing some logical operations. So this is really just copy and paste from what we saw before. But this in code is how I might compare two variables. Earlier I said I have no idea where x and y came from. Right? We looked at the example out of context. Now we have context. A few lines above, we're calling get int twice, storing the values in x and y respectively. So now x and y actually exist in my program. So here on down, I'm just doing the exact same thing that really big collection of Scratch puzzle pieces did. So if I compile and run this program, conditions.c, let's go ahead and see what happens. Make conditions. And now let's do /conditions. 1, and I'll type in 2. And logically, what should this actually print? Yeah, hopefully x is less than y. And indeed, that's exactly what the program does. If I run it again with 2 and 1, x is greater than y. And if I run it with 1 and 1, x is equal to y. So again, I've just translated Scratch puzzle pieces in this case to C to give me something a little different.